Okay.
So I mean, if I'm understanding, the preparation the preparation was the exam 4B review. There wasn't like a Google Hangouts prep, right?
Yeah, I think so. That's what I found.
Okay. Oh, and where's my paper? Yeah. So I know we had a little hang up last week, and I don't know if I managed to, I talked to the TA, managed to figure it out, which I think is actually something that we're going over today, about multiplying the tables. And I found this little trick. I don't know if maybe you saw it somewhere or whatnot, but the book actually tells you that whenever you're multiplying ones, like let's say you have a 3x1 times a 1x3, the matrices, if the inside values are the same number, then the matrices is going to be this, then you can multiply them, but then it means that the size of the matrices is going to be this first number by this last number, which is cool. And that's why the problems from Tuesday or Wednesday, whenever we did it, were that we were getting multiple things from multiplying them, and why it looked weird, because the outside values are going to tell you what size it's going to be. So
that makes
yeah, but we're sitting here trying to figure out why you multiply the same thing and it comes out two different ways, but no, it's just how you do it. Okay, let's see.
I could start with the pair if you want.
Oh, you're right. Totally forgot about it. I think we forgot that last time. My bad.
No, it's all good. Okay. Dear Heavenly Father, we thank Thee for this opportunity we have to gather one last time to discuss pre-calculus and to take the group quiz. And we ask Thee to bless us that we may be able to remember all the things that we have learned in preparation for this quiz, and that we may be able to move through this effectively and quickly. And I say these things in the name of Jesus Christ. Amen.
Yeah. Let's see. So prep. Okay, a sequence of lists is a list of numbers that has a pattern. Use the resources in week 13 folder. Oh, yeah. So, for the let me see. Was it the preparation? Or no. So I did the preparation. And I was looking at like the assignments here for the instructions, but by chance, because I don't know if it'll help with going over any of the other bit, would you happen to know what it was talking about? Well, never mind. We'll get to that, because I was looking over the extension problems, but
Okay.
I have like 50 tabs open. Let's see. Yeah, I mean, any questions from the prep work? Oh yeah, here are the instructions. Okay, ensure that each team member understands what a sequence is and how to find different terms, including recursive sequences. I felt that I felt that it wasn't too bad, actually. One of them I couldn't get for the life of me, so I had to while I was already asking for help on the matrices, I went ahead and tried to figure it out, because I had an issue with one of them, but I was just not using the right formula, because there's different formulas I wasn't realizing for whether it's arithmetic or geometric.
Gotcha.
So, and I mean, and I figured out the differences there, because I was having a little bit of a hard time with that, but I'm pretty clear on that now.
Awesome. Just trying to figure out. Okay. Yeah, I don't think I have any specific question.
Let me see. What are we on? You know the difference. Yeah, like the differences between the arithmetic, the geometric. Please don't mess with that.
Yeah, arithmetic is like if there's a a difference that you can get just by using arithmetic, essentially. And then the geometric is the ratio between the terms of the sequence.
Yeah, I thought those were
It out. Yeah.
Good. Sometimes I check myself by, even if it has like 15 terms in it, I'll type it out 15 times and see if I'm right. But the formulas definitely make it a lot easier.
Yeah, definitely.
I guess, yeah, so we can work on some of the extension problems and go over these sequences. Hey, I need you to stop that. My husband will be home in a second to get him, so that'll make life easier. But I know, you can still see it. Where it says go to the resources for week 13, I couldn't find this story about Gauss or whoever anywhere. I couldn't find it in the week 13 resources or in the con videos, or so I don't know what it's talking about here.
Yeah, I couldn't find anything in the resources either. It was just that one matrix thing or whatever.
Yeah, like I looked in the resources, and then I even looked in the multimedia library for all the videos of chapter. This is over chapter 11 in the textbook, and I couldn't find anything about that. I just found that that Gauss was a really good mathematician. So
yeah.
No, we're not going to do that. You can lay down. You can lay down, Joe. But so, and that's where I wasn't sure, where it's like using the formula you learned about in Gauss, find the following series. I'm like, well, I didn't find that.
Yeah. I don't know.
So I guess we'll just use what we've been doing. Maybe, but yeah, that's where I couldn't find this, whatever specific formula or whatever it's wanting us to use for this. Because this is using well, number 2 is finite, number 3 is infinite, and yeah, I was like, I'm totally clueless when it comes to that in the formula. But anywho, find the following series. Let me see what do we have a key for this one? Or no, we don't have a key for the extension problems, do we?
Oh, yeah, we should.
Do we? Oh, okay. So I'm wondering if for number 2, like, do you just get the answer that you would normally get for that many in a series given the first term and the last term kind of thing?
Yeah, there's an equation. Where did I write it down?
Is that the n over 2 one?
So for this particular problem, for the arithmetic series, the sequence must be finite using the formula you learned about in the story about follow this. Find the following series. Looking for, it just says find this. Is it asking like how many terms are in the series?
Yeah, see, that's what I'm saying, because it has, well, or is it just one? That's what I'm not sure. Or is it find the following series? So the series, is that the total of it all together, or is the series the number that are in there?
Let me look at the text.
Hey. No, what are you eating? Stop that. Where did you get this bread? You're gross. Yeah.
This is asking.
Okay, the sum of a finite geometric series. Is that what we're doing? Let me see. Yeah, using a formula, sequence must be finite. So find these. Okay.
So it's going to be the Sn equals A times 1 minus R to the N over 1 over 1 minus R?
Yeah.
Okay.
Okay, sweet. We're getting somewhere. Don't need a story. Okay, so what are you grabbing? Please don't grab the computer. Mommy's using it right now.
So we have this formula.
So A is the first term. 1 minus. And R is the ratio, right?
Yeah.
Why do you take my calculator? And N is that the number that are in the series, or we have to find N?
I know N is the number of this series, or the number of things in the series. So I'm assuming that's what we're looking for. Because we don't have a full, complete series here. We have this missing bit in between.
Let's see. Well, I looked at the answer key in the first one. It looks like we're looking for Sn, but yeah, we can't solve for that without N, but I thought I saw a formula for N.
That would be.
Sn roughly equals A over 1 minus R for large values of N. Doesn't make any sense.
I feel like the homework was a breeze, and then once it got to everything else, it was just like, now you're learning something completely new.
Yeah, like I'm done with all the homework, and I don't remember this.
I just don't remember it being this difficult.
It's like the first week I'm done with the homework before Saturday. So this is a finite series, and so this rule is different.
Where did my papers go?
Wait, if as I remember some of the first n terms. First n terms. So do we only count the first few terms? Oops.
So.
Oh. That is not the right answer. Oh, that's why. Still not the right answer, but
Oh. Okay. So we're gonna use an equals a1 plus n minus 1 times d, and d is the difference. D equals 5. An is 91. A1 is 36. Plus 5. So 91 minus 36 is 55. And then 5 and minus 1 equals 11, and then n equals 12. And so we can use that. We can use that to find s n equals. But there's no minute. I'm on to something. We're gonna use N02.
Here, let me grab the charger real quick.
1202. Plus 21 plus 36. Okay, I got it. So.
Here, sorry, give me 1 second.
Okay, no problem.
Oh, no, please stop. I don't need baggies everywhere. Sorry, my kitchen is covered in plastic bags now.
Okay.
So you got to get in?
So to get n, we use, oh, sorry. And we use this equation, the an equals a1 plus n minus 1 times.
Okay. Oh, and you have to solve for n.
Yeah, then I just plugged everything in. I found the difference was 5. So I just plugged everything in and then solved it and got n equals 12. And then after that, I took this Sn equation, which doesn't require a ratio. So it's for a arithmetic thingy.
Mm-hmm.
And so n over 2 times a1 plus an, and just plugged everything else in and then solved for Sn.
Okay.
Does that make sense?
Yeah, that makes sense.
Okay. And then the second part of that problem, it says, well, at least in the answer key, it says that there's another answer, which is 285. And I'm thinking use.
Are those separate problems?
I think, like in the answer key, it's clear that they are, but in the problems itself, it's like not very clear. I'm thinking it is though.
Yeah, that's kind of weird, but
So figure this one.
let's see.
Let's try this. So then, oh yeah, this one's pretty straightforward as well. You just have to find the first term by plugging 1 into that thing that it gives you. And then you find the last term by plugging 15 into it. And then using the equation we got, or we used for the last problem, the Sn equals n over 2 times a1 plus an. We plug in a1, we plug in an, and then we plug in n, because n we know is 15. which is the top of that sigma thingy. Plug it all in and we get 258.
Yeah, that one I actually got the answer to. Yay.
Nice.
See, so it does make sense.
Yeah.
Here, give me 2 seconds. My husband just got home.
Oh.
Sorry. Okay. Still not too bad.
Yeah.
So are those going to be on this test? Because I forget, I know some of this is on the test, or this will be on the final, I think.
Yeah, I think this will be on the final because it said the stuff that we learned for the first Google Hangout will be on test 4B, and then the stuff for the second Google Hangout will be on the final.
Mm-hmm. Hey. Stop freaking. Stop. Oh my goodness. This house is just crazy today.
Okay.
Okay.
Do you have any like specific questions about anything else, or do we want to move on to the quiz?
I think we can move on to the quiz because I mean now like it makes sense kind of how you explain it, like going backwards using the other formulas. Now that we have that new one, I can see. I mean, it's pretty much what we were doing like in the work, but I know it kind of takes it in a whole new direction sometimes.
Yeah.
And then for the infinite ones it starts on page 762 just for reference in the textbook if you had any other questions on like infinite or something, because I know sometimes some of these, like when it starts getting out there concepts, I do better by like reading it and looking at it.
Yeah, the infinite ones give me a little bit of trouble, but I think I'm starting to more or less understand them.
Yeah. No, so yeah, going on to the quiz, I actually did the first one.
The
But
so the Gaussian elimination thing.
yeah, because like I said, I had it open and I was like, oh, let me hurry up and get these problems through. And I was like, wait a minute, why are there only 3 preparations? Then I was like, I have the wrong tab open. But something that I actually looked up earlier, because whenever I was going through the homework, I was having a really hard time with this elimination because it just wasn't making any sense. Well, it made sense. It took me forever to do a problem. So while I was doing the homework, this gives you the Gaussian elimination method, but there's actually a Gaussian something else method that uses the same thing. In fact, it's the same work, but it goes in a different way, which I don't know if you can kind of tell, but you basically eliminate the variables, which is what you do in the first place. Is basically instead of making them 0, you just eliminate them. And then that's how you use it to get your answers. So I feel that this is a lot clearer. I can talk through it if you want, just because to me it made a lot more sense than just kind of looking and guessing of 1s and 0s. But it's the same method, same guy. So let me see. So here is starting out, like starting out with the 1x whatever. But you'll see in the first row we don't have a y value, so that one's blank and canceled out. So for this one, what I did was I times R2 by -2 and added it to R3, which gave me a new R3 row. But if you'll see, it canceled out this y because I'm trying to cancel out values. So I have like the x and the z in this one, the xyz in this one, and then x and z. So you just kind of keep going through. I multiply R1 by 4, add it to R3, and that canceled out this -4 here. That canceled out this -4. So then I got the value for z, but that'll reduce at the end. And then I just keep going through it to eliminate getting less and less variables. I eliminated the x from this row. I messed up on this one, but I times R1 by -7 to cancel out these. I kept going down until finally I got them down to these variables. I just didn't put the last step on here, but like x equals, what you're going to have to do is times R1 by 1 over -7 to technically divide it. Because, you can't just reduce it. But if you want the technical way, times it by 1 over -7, y equals -3, and then times z by 1 over 7, z equals -2, z equals -3, and x equals 4, or sorry, 2, -3, and 4. And I checked it out on the calculator, and those are the solutions. So instead of just kind of trying to make them all into ones and zeros, this system just cancels them out entirely. So your ones are just variables instead.
Interesting.
So I found it to be super helpful. It's called what is it, Gauss Jordan or Gauss Jacob method.
Where did you find this, you said?
So they've got it mentioned in the textbook. This is something, though, that I went over in my calculus course in high school, because I knew there was a system of doing this. The textbook mentions it, but they don't explain it very well. But I've still got my old notes and stuff from high school that I went and looked at when I was trying to do the original homework problems.
Okay.
But
that makes a lot more sense to me.
Yeah, see, and it is the same thing. It's just you're not doing everything with ones and zeros. You're just, if it's a zero, it doesn't exist. Yeah, and instead of the 1, you just keep the variable in its place. So then it kind of looks more like an equation to me, anyway. But I mean that's another way to work it out with the method. So I liked that.
I guess we can go on to number 2 then. If you were given any two matrices that were the same size, let's call them matrix A and matrix B, would K times A plus B equal K plus K times A plus K times B for the constant K? Explain your answer using an example. Would?
Well, I don't think it would, because I mean, it doesn't work like that in algebra. I imagine. I imagine it doesn't work in a matrices.
Oh yeah, because you have to add them together first and then times them. You can't times each part.
Uh-huh.
Ah.
Okay. Yeah, because if you had like 5 times 2 plus 3, that'd be 5 times 5, 25. But then 5 times 2 would be 10, plus 5 times 3 would be 15. And 10 times 15 is 150. So, I mean, algebraically, that wouldn't work. Explain your answer using an example. Does it want like a matrix example?
It just says using an example. I think simply by doing, like, just writing down exactly what you just said would be sufficient.
Yeah, because I mean, it's the same concept. I mean, whether you plug in the matrix or you plug in any number, it's not going to.
Yeah. So let's say K.
Oh, can you take the rolls? The oven's on. Sorry. Sorry, you're saying K.
Did you say, what did you say for your example? Did you say K equals 5 or just?
Yeah, let's put like K equals 5.
And then A can equal like.
It's an easy, something not 1. Because I know 1 will mess it up. Yeah, we can.
B can equal 4.
Okay.
We'll actually see if this works.
Yeah, 4, 5, 6.
Um,
So then that would be you had A equaling 2.
3.
Oh, sorry.
Oh no, fine.
So then,
So
so
then
5 times 12.
it's 35. And then 5 times 3 plus 5 times 4. Uh-oh. Well, this worked out actually.
Wait. No, because, well, 3 plus 4. Oh, wait. Why did I say 12? I multiplied them together. This isn't cool.
Huh.
Maybe it does work. Let me do two different numbers. Let me do 5 times. Let me do 2 and 6. Let's
For
see.
A and B?
Yeah.
Okay.
Okay, maybe my logic was false.
Oh, yeah, because they do in fact equal each other.
Hmm.
Interesting. Maybe would you be able to multiply? Oh, whoops. Would K, for any constant K, maybe it can.
Maybe here, I'm gonna throw in 2 matrices in my calculator,
Uh-huh.
and I'm just gonna make them 2 by 2s with like basic numbers
Okay.
and see if I can do it with a matrix on the calculator and see if that equals. Okay. 2, 3. Oops. So it's going to be, so let's make K 5 again. No, let's make K 3 because 5 is bad. Matrix B. Okay. And 3 times matrix A plus 3 times matrix B. Yeah, so they do come out to be the same.
Interesting. I guess
So,
use this like one of these things as our example and just say, yeah, it does.
okay, sounds good. Because yeah, both in the equation and yeah. I didn't think it worked as I tried to do it in my head, but never mind. Learn something new.
Learn something new every day. Okay. Would you be able to multiply an M times N matrix with an N times P matrix?
So that would be yes, since they're 2 inner values. Excuse me. Achoo, 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 achoo. Whew, excuse me. Thank you. Since their 2 inner values are the same.
Yeah. If so, what would the size of the resultant matrix be? It would be M times B, or M by P.
Yeah, so that would be, so you can multiply them together and then that would be the size.
Yeah. So let me just write that out. And yes. And then results B There you go. Okay. Convert this decimal to a fraction by writing the repeated decimal as an infinite geometric series. How does it work? Convert 0.181818 to a fraction by writing the repeated decimal as an infinite geometric series.
Yeah, I don't know what that means. Well, let me jump in the textbook. Can we use the textbook? Yeah, we can use it. Finding the sum of an infinite.
Yeah, we can use the textbook. Is that what you said?
Yeah, I was checking real quick. I was like, wait a minute. I've been jumping at the textbook this whole time. Okay, first term is...
It says we can use our textbook if that's what you're wondering.
Yeah.
Oh, okay.
Oh, here we go. Page 764. Repeating decimals to fractions.
764.
Okay, let me double check. 764.
Okay, repeating decimals to fractions. Write the repeating decimal as an infinite geometric series. Okay.
Is that what we're doing? Yeah, that's what we're doing. So the first term, would that be 0.18 since it's 18?
Thinking, yeah.
Okay, first term is... Okay, so the first term is... The ratio is 10 to the negative 1. Why is it 10 to the negative 1?
That's just saying that so this thing has all the way down. And so the first one is just 0.3, and then 0.3 times 10 to the negative 1 would move that 3 one space over. And so we have that second 3 in the line, and then to the negative 2 moves it 2 spaces over. So we have the third 3 in the line, and etc.
So would our problem be negative 2 since it's two decimal places?
I think so, yeah. So we have our A1 as 0.81, and then we have A2 would be 0.8 or 0.18 times 10 to the negative 2 because it moves it 2 spaces over. So it would start to look something like this. So we have the normal, then we have times 10 to the negative 2, and then we have 0.18 times 10 to the negative 4. Okay, we got that part. The first term is the ratio. So the ratio for us would be 10 to the negative 2.
Yeah, that's what I'm pretty sure.
Use these numbers in the formula for the sum of an infinite geometric series. The formula is S equals A1 minus R. Oh, and then we just plug it in. So
okay, and that turns that into a fraction versus a repeating decimal.
Yeah.
So then
0.18 1 minus R, which is 10 to the negative 2. Okay, let's see if I can make this in.
Of course, my calculator gives me a fraction. Let me see. And as a fraction, it comes out to 2 over 11.
Yeah, that's what I got.
So, did it want the fraction as well?
Let me look. So,
well, I guess, I mean, it ain't gonna hurt.
Oh, this is what we're looking for. The 2 to 11, or 2 over 11, I think is what we're looking for. Because it just convert to a fraction.
So we write it out as a series and then show it with the formula to a fraction.
Yeah, and show how it says show all your work, so we need to show how we found R, which is super simple. And then
Okay.
show um,
Okay.
yeah, I think that's it. Unless I'm not seeing something, I don't know.
No, I think that's exactly it because that's what the book said.
Yeah.
Okay, awesome. Well, I've already got one all written out. If you want, I can go ahead and just submit it.
Okay. Do you need anything that I have, or do you have everything else too?
No, I've got all the rest of it. I was writing it down as we went. Yeah, I feel pretty good with this quiz and the last one too. So
Yeah, same.
fingers crossed. It's not like, oh no, it's actually a 0.
Oh.
Hopefully not.
Yeah.
Well, that sounds good.
It's been a fun semester.
Yep. Good luck with are you chemistry? I think.
Yep.
Yeah, sciences are awesome. You have a good one, okay?
Yeah, you too. Bye.
Bye.